So now, students, let's talk about inverting inverting operational amplifier. I have told you many a times that I have a very bad handwriting, but still I'm trying to improvise it. So, in case of inverting operational amplifier, certainly the signal that we will subject to would be to the negative terminal of the operational amplifier. So let's go with the diagram here, and let's. So this is my operational amplifier. Let us assume this is the negative terminal, this is the positive terminal. So from here we have an input resistance, and we have to invert the signal. So here we would like to subject our input signal, and it must have a voltage Vs. Here we have a resistance Ri. This operational amplifier has an output. Let us assume that output is Vo, and it has a non-inverting terminal here, and we would like to ground this non-inverting end of the operational amplifier, and the voltage of the signal is Vs. Then a part of its output, we would like to subject that back to the input, right, like this. So let us assume that the resistance, the feedback resistance here is Rf, and this is the story about it. So let us assume here the voltage is V2 and here the voltage is V1, right? Now we can analyze this circuit analytically, and look for the KCL, and use the concept of virtual ground to get the final expression for the calculation of the gain of inverting type of operational amplifier. Now what is important here in this case is that it is an inverting operational amplifier. That means the signal that we are subjecting to this operational amplifier will be out of phase by 180 degree at the output, right? So the feedback that we are doing here is the negative feedback. We are making use of the negative feedback in case of this circuit. Right now, if that's the case, let us start it somewhere. Say for example, let us assume that we have a current here, and in this case, I would like to have, yeah, this will be my here I will have IF. Okay, then let me suppose that the current is coming from this direction. Suppose this is I, then it will go like this. This is IF, and it will go like this, and this is I1. So at this junction, say for example G, so at junction G, we can make use of KCL. Okay, we can make use of it, and we have I equal to IF plus I1, right? Again, the concept is quite clear here, is that the input resistance of this operational amplifier is infinite. If we think of an ideal operational amplifier, so in this case, the input impedance, say for example Zi, that is infinite. So if that's infinite, then we can say that the current that can pass between these two terminals, that I1 is equal to 0. So if that's the case, we have I equal to IF. Now let's write down this equation in terms of voltages and currents. And what we can do here is that we can have Vs minus V2 for I. Okay, Vs is here, V2 is here. Okay, that will be uh, the voltage drop, divide by the resistance is Ri. So for I, what will be the case? For I, we will have what we will have. We will have Vs minus V2 divide by Ri. Okay, so that's for I. For If, now for If, here the voltage is V2, and here you have V out. So this must be equal to V2 minus V out divide by Rf. Okay, that's the case. Now we can simplify this equation, and we can look for the output voltage. So this is Vs by Ri minus we have to look for V2 here. I mean, see, what we would like to use the concept of virtual ground here. Okay, now what is virtual ground here? Now, for virtual ground situation, what we have, since the no current is flowing between this point, since no current is flowing between this point to this point, so the potential at this point is equal to potential at this point. So for if we make use of virtual ground here, then the V1 is equal to V2, but V1 uh, uh, is at if we think of V1 with respect to the ground, it's at zero potential, so it must be equal to zero. So if V1 is zero, then V2 is also zero by making use of the concept of virtual ground. I think that must be clear. Now, in that case, we will be left with Vs by Ri is equal to V2 is gone, it is minus V out by Rf. All right. So from this we have got the gain, the output voltage that we will have for this inverting operational amplifier. Now that will be Vs times Rf by Ri.